a representation for K. We know that F is a force, we know that U is the displacement, but we need a value for that K. And that's the purpose why we're working at this at the moment. So, we get these two expressions, this and this, but it's still nowhere near this one. Okay? We still want to get an expression where if we have F here, very clear, we have U there and we have a K here. So how do we do that? Now, have a look again. Sorry. So have a look at this one here. Yes, what can you see here? We have du dx. Let's work on du dx. What is du dx? So earlier we were able to establish that U is equal to N1 U1 plus N2 U2. And then that this one is equal to N transpose multiplied by that UI. Just going to put here matrix. So earlier we were able to establish this one already. So we're going to put this value here. So d dx. So that will be N transpose shape function transpose and then your UI. So I'm just doing this one little by little in order not to scare you too much. So step by step, there is, what else do we do? So have a look at this one here. So what do we do with that? So what we can have here now is that what was our previous equation, by the way. So we have this one, right? So again, it's just trying to write two things here. So this one now is d dx, and then we have now here N1 U1 plus N2 U2. Okay. So we can multiply now that. So this one now is not a function of x, assuming that this is not a function of x. So we have now here, because it's not really a function of x. So M1 is a function of x. N1 and N2 are a function of x. So dN1 dx U1 plus dN2 dx U2. And what do we know about dN1 dx? So this one is b1 u1 plus b2 u2. And this one is b transpose u I. The derivative of your shape function with respect to x is equal to your strain displacement one now is du dx. So after getting du dx, we can now substitute it here. And here. So yes. Let's have now here. I'm going to rewrite now again our equation. F1, I'm just writing out this one in a different form or in a different, just changing the left hand and the right hand side. So we have now here d1 du dx dv equal to, or sorry, that's it. So F2 is equal to the volume integral v2e du dx dv. But we know that du dx is equal to v1 u1 plus v2 u2. Or you can write this one as v transpose ui. So this substitute there. So F1 now will be equal to the volume integral E1 multiplied by E multiplied by V transpose UI multiplied by, dV. There you go. Yeah, I think it's getting better now, yes? Yeah, it's getting better, really. So we can have down here F1 is equal to the volume integral. We can bring this one out. So that's B1E V transpose dV, and then we have now here UI. If I'm going to write F2, F2 now will be the same. Volume integral, so V2E V transpose dV UI. So you probably get the drift now. So if you add them both, then you'll probably end up, you're going to end up with, so you get those, blah, blah, blah. So when you add both, you'll be able to get this one here. So this one is F1 and F2. If you try to work on this one, what you're going to get here will be, anyway, everything is here. The steps are here, so I'm just going to shorten it. So as you can see there, and then you will be able to get this one here. So what I'm saying is that you will have F1, F2, so this will be equal to the volume integral, right, of that matrix B, and then you will be able to multiply this one with E, and this one will be the transpose dV, and this will be UI. So what will happen here here is that you have Fi equal to the integral of this one, B E. Yes? So this is your F. That is your K. And this one will be your U. So we're not finished yet. We want to get the symbolic value for